Good morning. As Jay mentioned, this is Jeff Weaver with C&E Advanced Technologies. I am an automation specialist for Ohio and Northern Kentucky. We additionally have automation specialists in all of our territory: Indiana, Kentucky, Tennessee, specialists for vision, motion, safety, and sensor. Today we're going to be talking about the ever-popular topic, the Industrial Internet of Things. It's somewhat exhaustive, so it's not as if we're covering every possible option. However, we're going to give a good overview of what the IIoT really involves and a solution for how we can bring IIoT into our facility as it is now without layering in 3 or 4 different software companies. So with that, I'll get started. The overview, we're just going to look at the IIoT, what this really means. Then we're going to look at some solutions we have in-house here for getting to actual cloud-based data. So what is the IIoT? Well, if we look back at a more traditional approach, we start with a PLC or a whole plant full of PLCs. Typically, it is the PLC or controller that we're dealing with when we come to getting specifically plant floor level data. That would typically then integrate with at least an HMI and then potentially even a SCADA. Now a SCADA stands for Supervisory Control and Data Acquisition. That was a higher level HMI basically. That one involves data acquisition. It's usually got better interfaces to other PLCs, but it also typically has better interfaces upwards to other data options. Usually SCADAs come with a lot of option packages as well. Usually the automation person or people involved with programming the PLC would also be involved with programming the SCADAs. Not always, but usually. From there, we typically would then, and I say typically, that is assuming that the solution or the process actually moved into the next level, and that would be MES layer. And that's where we're going to do a little more analytics on the data and actually do some storage. And actually, we get into full storage, we're going to move up to the ERP layer, and that's where we're going to get into some SQL Server stuff. Very seldom do we move from ERP down back into the PLC. However, there are instances where we do. And more often than not, we don't even move this far up the ladder, because with each one of these layers comes an additional set of software and tools, sometimes additional hardware. And more often than not, this is not one person involved or one group involved. This is typically going to be multiple layers. Now, this is not the only way we've done this. Another way we've handled this is throwing in an OPC server. That's very common. Often the OPC server will actually sit between the SCADA and the PLC. So in that instance, a SCADA may be talking to a variety of PLCs and uses an OPC server to get to all of the PLCs. So that's a common approach. I've used that one as well. So maybe I have some Rockwell, some Siemens, ironically I had some Toshiba, and I'd use an OPC server to communicate with all of those devices, and then the OPC client built into the SCADA could then read that data. The OPC server also will often go directly to the MES layer. So I've worked with that as well, where sometimes an MES software package will have OPC client capability talking to the OPC server. And then, of course, from MES to ERP, and usually as automation people, we don't get involved in that connection. Another option is actual hardware that goes direct to either MES or ERP, essentially a database. So I've used hardware like that. Some of it's rack mounted in the PLC, some of it's standalone. That hardware still exists today, so if I wanted to go direct to, say, an Oracle DB or a SQL Server database, I can do that with some of this hardware. And when we're dealing with a SQL Server database or something of that nature, then we're dealing with something that is managed and on-site, typically, with the end user. I've had situations where the SQL Server database, for instance, was not on-site, but it was still managed by the end user at a wide area location. So these out here, the OPC server, hardware direct. Those are our alternative ways to get up into that stack. Certainly, we have other options for that as well, or other ways to get it done, but these are just some traditional approaches. But the reality is we just want data, especially that, we want to be able to track our processes. We want to be able to do some preventive and predictive maintenance, do some monitoring, and we don't necessarily want to deal with these layers to get there, but that's been our only approach up to now, and that is where the IIoT comes into play. And that's where we go direct from, say, the PLC up into a cloud-based solution. Now this shows the PLC, or machine process data, but one of the surprising turns, at least for me it was surprising, that I've seen taken in the IIoT is that we are now going direct from devices to the cloud as well. Today's solution, we're going to do a little bit of that. And I think that's going to be very common, not just to go from PLCs, which obviously the PLC is essentially just a data warehouse. It's very capable, our PLCs today. But we're also going to be going direct from devices into cloud-based solutions. Now, there are multiple ways to do that. One of the common ways is using MQTT messaging and a publish-subscribe model, and that's a valid way to do that. With the solution we use today, it's a little simpler than that, so it makes it very easy to implement, but it's still the same type of system, and we're going to be able to get device data and device data monitoring, production statistics, we can log production data, downtime reporting, predictive maintenance, and remote monitoring, such as maybe a tank level or pressure levels. So we're going to be able to get that data very easily in a cloud-based system. Now when we're in the cloud, we can get to that from our smartphones, we can get to that from our PCs, and that data is stored and, of course, secure. Now what we will also start to do is have interconnections between some of these other layers and the cloud. So that makes it so that we're not dealing with so many different sets of skills to get to and from our data, and we're getting directly from our data to the cloud much simpler. So that was a little bit of an overview of the IIoT. There are a lot of different ways to look at the IIoT, and you'll get different explanations. The ultimate objective of the IIoT is to connect every potential device. Every device becomes smart, and we want to have every device connected to either internet or cloud. That's what we're talking about with the IIoT. So it's the piggyback or a subset of the IoT, the Internet of Things. So with that, I'm going to present our solution, or one of our solutions. Should not say it's the only one that we have. And that is Banner Connected Data Solutions. So with Banner Connected Data, this is an actual website and server that allows you to host your data in your site with your equipment. Pretty painless to get going, and the dashboards are built in. So this is kind of a directional view. We're moving from embedded, as I mentioned, the SQL Server databases, those sorts of things. We're moving from that environment to cloud-based. It's putting less burden on the end user to have that data stored. Hopefully, we're moving from reactive to proactive, and instead of focusing on individual parts, we're looking at a solution. So what are the components of the Industrial Internet of Things? Well, first we've got to collect the actual data. And we're going to see here, this one, for instance, we're showing some temperature, humidity, maybe pressures, motor monitoring, such as temperature and vibration, tank levels, individual values. Those are, right now, we're showing this path on into a PLC. But as we're seeing, we could actually be going direct into the cloud without going first through the PLC. So that is becoming common. And then the end result is that we're going to end up being able to have data sent to us, FTP. It could be that we just want to go access the data. We may be going back and looking at different periods of time. We want to get alarming sent to us. We want annunciation. We want to be able to access it at any time from a smartphone. That's the end objective of this data. With a Banner solution, one thing that we can do is potentially be all Banner all the way through. So this device that's sitting here in between collection and transmission, that is the DXM100, although we have three varieties there, DXM100, 150, and 700. That is the gateway that gets us into the cloud, and then on the other side of that gateway, we can get direct to devices. So if I look at the devices I'm showing here, I could be pulling data from level sensor. It could be discrete data, even do parts counting. You see down here in the bottom left, this is one that we're going to demonstrate today. That is the temperature and vibration sensing on a motor. Very helpful for predictive maintenance. All of that wirelessly back to this DXM controller. DXM controller then connects to the Banner Connected Data Solutions, and then you get out of the Banner Connected Data Solutions that data that we want. One thing I want to stress is that this DXM, we have other methods for getting data into the DXM. So it would not have to be strictly Banner data that we bring in. And that's critical so that you can actually collect more than just those individual sensors. The value of the system. Sorry about that. For one, it's simple. Very easy to integrate, and we'll see that. I'm going to actually add the device today. I'm going to add the actual individual values in the device so you can see how easy it is to get rolling with this. You're going to get an immediate value, so OEE, for instance. We actually have solution guides for these, and I'll talk a little bit more about that. But that's a piece of data you may already have in your PLC, and we just want to bring the data into the DXM. So that's certainly capable or doable. Events, so we can send emails, we can send SMS messages. I'll talk a little more about how we do the SMS as well. The big data, basically, the Banner CDS is going to store and load your data. And you can actually set what requirement you have. There's a data calculator on the Banner CDS site as well, so that you can have a good idea how much data you're going to need. And at this point, it's an end-to-end solution. From the sensor all the way up to the cloud, it's all a Banner-based solution. However, again, the Banner is not limited to talking only to Banner devices. So we'll look at that. The Banner CDS site, very simple. www.bannercds.com, and that's where you could actually go into subscriptions and run the data calculator and find out how much data you're going to need. What do you get on the Banner CDS? So this is a nice view of a dashboard. So here we're looking at what probably is some vibration data, just looking at the response of that chart. These charts, these objects, they're basically built in. They're very simple to configure. You're simply going to link these to a tag, maybe set some limits. So I can show you how we do that, and that's what we're going to do today. Alarming, condition-based alarming, very effective. So now I can say, well, on all state changes, whether I travel up through an alarm limit, a warning, or a fault, and then I travel back down through, I can send messages on all of those, or I can simply send it when I'm escalating. These conditions, I can also pop online and look and see what condition it's in currently, but it's going to be emailed to me based upon the setting of my alarm threshold. And again, we'll do that today. You'll see how quick and easy it is to get going with this, and this is not a multi-discipline approach to get to this point. Device geographic information, or geo information, health status, so we can have that built into each one of our devices. When I say each of our devices, I mean our DXMs. We could actually store and send out the FTP data. So we could shoot, say, FTP data out maybe once a week and just send that to our FTP server, access that very easily as well. I can send data to my email account. I can do that as well. Very, very simple to do. Custom graphing. The graphing is really just as simple as adding variables to the graph. So you can say, I want a graph. You go to the graph tab. Actually, you can also do this on dashboards. And I want a graph. In this case, it looks like it's probably motor. Looks like it's motor vibration data. What's nice is you can also actually throw in the warning level and the alarm level. So in this case, you can see the warning and the alarm level, and that we're well below that value, including also the baseline. So very effective in being able to see exactly where our data is relative to the alarm points. And we're putting all of that on the same graph. So here we're actually able to look at how many data points am I using, how often have I been using them. That's what our subscription is going to be based upon. So it's a way to pop in and actually verify how much data I'm using, and maybe I need more, maybe I need less. Additionally, I can add, which makes perfect sense, users for my sites so that as many people as I want can get into this, but I can limit, of course, what their capabilities are. I don't necessarily want everyone to be a super user, but maybe I want everyone to be able to see the data. So I can simply create recording or create users for that. Fleet management tools, this is a pretty handy one. Each one of these, this is the site tab within the Banner CDS. Each site is essentially a DXM. So you could have multiple DXMs in one particular facility, but you could also have them spread out across many facilities. So each one of your DXMs is considered a site. And then I can get some information on that just by expanding that particular site, find out if it's online, what method it has for pushing data up to the cloud, if I have any alarms current. So it's a nice overview of each of my sites. If you were to select documentation and support, it's pretty handy. We have videos, solution guides, and I've mentioned the solution guides without really talking about those at this point. But the solution guides, some of the options that we have within those solution guides, we can have call for parts. We have a nice call for parts solution that's designed to wirelessly send out to maybe a handful of forklifts, so that if a particular station calls for parts, forklift is going to get enunciation. First forklift to respond to that will then acknowledge that to all the other forklift drivers. That's a canned solution. It is something you can download from Banner and simply install the script in the DXM. Of course, you need the hardware, and that will run. Another one is temperature and vibration, which we're going to demonstrate today. But the temperature and vibration can also, we have a canned solution for temp and vibe, where the baseline for the vibration data and all the necessary calculations are built into the scripting. You run it and install it, and then it will take care of those variables for you. Additionally, we have a complete OEE solution where we're doing parts counting on a Banner wireless node back to a Banner gateway or DXM, and then it will generate the OEE data, production data automatically for you. Again, these are just built into the scripts. Some of these solutions you may have your own solution for, but you want the data to the DXM. So I may be calculating OEE or FTC. Some of these quality parameters, I may already be calculating these. I just want those on my Banner CDS site. So in that case, I'm going to communicate with the DXM and just basically send that data to the DXM without the DXM doing any calculations. So on the support site, videos, very useful video library, solution guides, the solution guides I just mentioned. Once you've logged in, very easy menu structure to work through. This Banner Connected Data Solutions Instruction Manual, if I were to expand that, it leads me through each piece of the Banner CDS site, every tab, every possibility. It's pretty handy. Sort of a forums set up as well, so that you can post questions. Key applications we would want to focus on, specifically with the IoT. Let's make this thing actually work and do something. I think there's this question mark with IIoT has been, what do we do with it? Well, that's the point, is to actually use the data to make ourselves better and more efficient and less costly. Predictive maintenance. So we're going to look at that today, just motors, critical assets, temperatures. Condition monitoring. That's where I can simply trigger an alarm from, maybe it's a PLC, or maybe I'm looking directly at a sensor that says, okay, my tank level's too high, too low, high or low temp, loss of pressure. I can trigger an alarm based upon those events. Then, of course, OEE. Every production manager wants quality data, OEE data at his or her fingertips at all times. So those applications are canned, and those are the most common. So I mentioned the solution guides. These are 4 solution guides. A banner, when it's a solution guide, it's almost really a kit. So you can buy the hardware as a kit and then pull down the scripting and install that within the DXM itself, and pretty much it'll run. It'll do everything it's pre-designed to do. Frequently asked questions: who owns the data? Well, the customer owns the data, so you own it. You absolutely own the data. You can choose what to do with it. Banner provides the hosting. Banner uses Amazon Web Services, so AWS is the hosting platform. Security, it is encrypted between the DXM. The data is encrypted between the DXM and the Banner CDS. Additionally, you can switch to the certificate-based encryption as well. So the certificate resides in both spots, which is a very common method for encrypting your data. You can get to this Banner. If you have an interest in Banner CDS web services, contact us, C&E. We can provide the part numbers, but also look through the application with you and look at the hardware you're going to need. Lots of solutions we can incorporate. And then, of course, there's the Banner CDS site. So these are some of the part numbers. All right, so we've talked about what the Banner CDS does. Now we're going to talk about the actual nuts and bolts for how we get there. So we are going to get out of presentation mode and actually do some stuff here in a minute. So this is the DXM, one of the DXMs. And you can see right on the screen there, you have very interactive information. Pretty handy. There are times when you need that, certainly pulling an Ethernet address or verifying. You have, notice this one has 2 antennas. One is the wireless antenna for its sensor network, and that's the DX80 style sensor network. And if you're not familiar with DX80, I'll talk about that here in a moment, just to bring you up to speed a little bit. Additionally, you see this other antenna. That could be a cellular option. So the Banner DXM can communicate, and today we're communicating just straight Ethernet, getting a DHCP address or even a fixed address from my local network and traveling on out to the internet. No public IP address is required here. Also, though, I can use a cellular card and go direct cellularly. If I truly want to send a true SMS message, it has to be a cellular card DXM. However, I choose to send my SMS messages via an email. So, for instance, my phone number at vtext.com is the address for a Verizon email, and then Verizon will turn that into an SMS and send it out to a phone. So that's how I do that with an Ethernet-based system. So what can the DXM do? Well, for starters, wirelessly, it can read I/O from DX80 style devices and sort of a star topology where the DXM is at the center. We can also hardwire. The DXM has built-in I/O, but communications is where this becomes pretty effective. We have Modbus RTU, Modbus TCP, and then it has Ethernet IP built in. So the DXM can actually be an Ethernet IP device of another PLC, compactor control logics. Built into the DXM, as I mentioned, you could have the cellular modem, certainly the wireless as well, the SureCross radio. That's the Banner wireless radio. But we also have some IoT messaging functions within the DXM. In today's example, though, we're going to do most of those IoT functions from the Banner CDS. And I threw this in to explain what the actual wireless system is if we're doing wireless. The DX80 system has always been a star topology, so an individual node might be reading a sensor, and then that sensor is going to be, its status of that sensor, or the value of that sensor is going to be sent back to this central point in the star, which was the gateway. The DXM actually sits right in that spot now. So the DXM is the gateway, but it also provides connectivity to other devices, and of course it provides connectivity to the Banner CDS. Supported automation protocols, Modbus RTU, Ethernet IP, Modbus TCP. We have additional protocols on the way, but those are current. So I mentioned the DXM sits in the middle. This is where we sit now, so we could be pulling directly data from motors, so we're not doing that with a PLC necessarily. We're going straight from, say, motor temp and vibe sensor direct to the DXM, and then the DXM is going to go direct up here to the cloud, which is again our Banner CDS. And then at that point we can read that information from smartphones, from web server, for web browsers, etc. So this is a little bit repetitive, really. Predictive maintenance, condition monitoring, OEE applications, we covered that. So this is what we're going to do here today. So I want to walk through this. It's a little busy what's going on, so hopefully we'll make some sense of it. Everything starts with the DXM100. And then I'm going to connect to a switch. It does not have to be a managed switch. However, if I made the DXM100, just an extra note, if I made that DXM100 an Ethernet IP device to a Rockwell PLC, we would always recommend that your switch have the capability of IGMP snooping with its querier enabled. That is required to sort out the multicast traffic that inevitably occurs in an Ethernet IP network. The device itself can be unicast or multicast. However, it's just one of those precautions you should always be taking with an Ethernet IP network. So we're going to connect the DXM via Ethernet to the switch. So in our today's example, this would not need to be an IGMP snooping capable switch. So then we're going to use a device, if you're not familiar with it, called a Redesigned data station. Now I'm using that device because the data station has a plethora of drivers, and we can communicate to lots of different devices in the data station and then just hand that data over to the DXM. So that's a very effective solution with the DXM. So right now I'm communicating with a Banner DX80 gateway, which is communicating to my wireless temp and vibe node. Now traditionally, in an effort to fully disclose here, traditionally I would be communicating directly from the Banner vibration temp wireless node directly to the DXM100. The reason I did it is because my equipment was 2.4 gigahertz instead of the 900 megahertz that the DXM100 that I have is actually running. Now to touch on that, the wireless is basically secure. Not basically, it is secure for a variety of reasons. For one, 900 or even 2.4, it's not going to be read by other devices. This is proprietary. It uses, when we're dealing with wireless communication, something called a frequency hopping spread spectrum. So it's a pseudo-random hop table. So what that means is, if I'm looking at this DX80 and it's talking to this node, and if this were 900 megahertz, it'd be a spread spectrum between 900 and roughly 925. It's going to hop from frequency to frequency. And node 1 may be at 907 megahertz this time around, and the next pole I'm at 912. Well, that seems random, but it's pattern built in and exchanged between the two devices when they're first linked. So that random hop table is what gives us that security, plus the fact that we're a proprietary packet out on the wireless. So you certainly wouldn't see it with any normal wireless device to begin with. So what we're doing today is we're going to communicate from this DX80 gateway into the data station via Modbus RTU, and then we're just going to map the data directly into Modbus TCP over to the DXM100. So we're using that Modbus TCP piece today. Additionally, we're going to communicate to a Rockwell PLC. In this instance, I'm communicating to the Rockwell PLC from the data station, and then the data station is passing the data to the DXM100. But we certainly could go the other direction, where we had this single PLC be the Ethernet IP IO controller controlling the DXM100 and exchanging data in that way. And that's very common for us to do. But I wanted a variety of PLCs, which is why I stuck with the data station. So I'm also going to communicate to a Siemens S7-1200. So in my DXM100, I'm going to be pulling data, just in this one example, directly from wireless network, also from a Rockwell PLC and a Siemens PLC. So that is the solution that I'm going to implement here now. So with that in mind, I'm going to switch from the presentation to the actual software. So here I have a software utility that I'm going to use to program my DXM. Now, normally you would have this brand new out of the box, and you could verify the IP address of the DXM just by looking right on the face of the device and scrolling down into the Ethernet settings. However, mine is already set up at an Ethernet address. But I am going to start with a fresh application. This is the DXM configuration tool. So this is how we're going to actually configure the DXM 100. First thing I'm going to do is connect to the device. So device connection settings, and mine is set at 192.168.8.111 at the moment. And then I see down here in the lower left corner of the software that I am connected. If I select the settings tab for the DXM, this is where I'm going to set up the basic settings of the device. Something like I'm going to get time from the device, and then I can sync that time with a PC. So we'll set that for Eastern time and sync it. We're going to set the cloud services here in a moment, but that will be the last thing I do. So I'm going to move over to the network tab, just run through some housekeeping. Now at the moment I already have the settings built in, but if I were on a plant network, I very well may be setting this simply to be DHCP, but if I do want it to have a fixed IP, I need to set that here, because when I download to this device, if this IP is not correct or the DHCP server doesn't exist, then it is simply not going to work. It's going to be defaulted back to whatever was set in this IP. Now I really don't need DNS addresses here because of what I'm doing. If I were doing DHCP, the DHCP would assign DNS. If I were doing mail server out of this DXM, that's where I would likely need my DNS. I'll go ahead and enter the Google DNS. But that is not required at this point. So there's my Ethernet settings. If I go to, I'll go ahead and save here. I'm going to go ahead and configure my cloud service, or at least look through the beginnings of that. So I've saved the file. Now this is saved, but it has not been sent to the DXM device, so that's important to note. But before I configure the cloud, I want to be sure that I'm actually reading something. So I'm going to go to this local register and do a test. Just call it test register. And if I expand this local register, these local registers are what are actually going to be pushed into the cloud. So I'm going to select this. I'm not going to give it any units at the moment, but I'm going to select it to be a read within the cloud, and that is it. That has been set. I do still have to set the actual cloud setting. So again, I'm going to save that. So within the cloud setting, I need to have the correct server name, and then I'm also going to need this site ID. And that's going to get me what I need. I also will set the cloud push interval. So for me to do that, I need to go over to the Banner CDS site with my login. So I'm going to switch to that site. And we're going to add this device from scratch. So here we see I've already got one created, but I'm going to go ahead and add a new one. So I'll select new site, site name, and I'll save that site. Now if I expand within the site name, this site ID is required. So I'm going to copy that over in my DXM software. So you're going to see this is a pretty painless process. I mean, there are a couple of steps, but it's not really difficult. So here is my site ID. I do have, because this is the demo site, I do need to change the server name. And now that is set. I want to change my cloud push interval to 1 minute. That typically might be longer than that, but that's what I'm going to change it to here. And again, I'll go ahead and be wise and do a save. Now I'm going to send this configuration. Now this is actually downloading this configuration to my DXM controller, and I have to pick which configuration. On the controller itself, I will see the screen light up when it reboots. It lets me know that it received the data. And now I need to take this XML file that I just created, and that needs to be loaded into my Banner CDS account. So I'm switching back to the CDS account, and what I need to do is essentially link up the configuration of this device with this account. And every time I add registers, I'm going to need to do that. So you'll notice here, if I select options under the account or at the account, it has no XML file at this point. So I need to get it to an XML file. So I'm going to drop in so there's the XML I just created from the software. Now I'm going to say within the Banner CDS, I want to update the XML. I browse, I select it, I save it. So now if I select the registers view, register of my Sensonics, I need to select this site, which again, each site represents a DXM. There's that test register that I created. Now it has nothing in it, so I'm going to go back to, I created that just to verify communications, just so I'm happy and I see stuff happening. I want to go into my DXM 100, right to that local register something. So here I've written a 77. I want to read it to make sure it's in. It is. And remember, we're on a one minute push, so I may not see that for 1 minute over on the main site. So I'm going to move on to the next piece of this while I wait for that to update. So I've created within my local registers that test register. I'll leave that alone. And the other piece of this central piece, remember, was our Redline data station. So this Redline data station is going to communicate with several devices. So for starters, we're going to communicate with the other gateway, the DX80 gateway. And we're then going to communicate with the DXM itself, and that's over on the Ethernet side of the communication. And then we're going to communicate with the control logics and it's compact logics and a Siemens S7-1200. I'm not going to walk through the entire setup for those, although it is pretty painless, and again, we could help you with that very easily. No issues there. So let's go ahead and look at some of the registers I have configured. So within the control logics, I have added just 3 or 4 registers here. Machine status register, which is an int, and then 3 booleans: machine down, machine needs maintenance, machine run. If I switch over to my Siemens, I have something similar. I have an alarm register I created. Machine is good, machine is down, or machine needs maintenance. So just some simple registers, but I'm reading out of 2 PLCs plus my wireless data. So I want to be sure that the settings are correct here. That looks good. Okay. So I'm going to go ahead and link some of these local registers with my data here. So if I looked at my mapping here within the DXM, I've mapped this data already. It's pretty easy to do this, but I want to go ahead and match that up. So I'm just going to create these local registers to match what's coming into the DXM. So we'll call this one motor 1, temp, or actually this one is Z. The temperature vibration sensor will pick up temperature, of course, but it will also pick up vibration in two different directions. It'll have two axes. One is the Z, which basically runs straight down through the motor. The sensor sits right on top of the motor housing. And then the other is the X, which is basically in line with the shaft. So the Z axis and let's see, what do we have coming? So motor 1 temp. I'm going to pick up some of those control logics pieces now. So that was and then I'll do the same for the S7. Yep. Okay. So now I have to set, as I did with the test register, and set the cloud permissions to read. I'm going to need to do the same for each of these variables. And in this case, I'm going to say the units will be custom. Those are in inches per second. Motor temperature, we'll say the units are Fahrenheit, and it's a read again. So just setting these pretty painlessly, each variable that I want to bring over. Make sure I set each one of these to read. Status is not on off. See, this part's a little bit monotonous. Might have chosen to do too much of this, but there we go. So there the local registers are set up. One additional step I have to take, though, is I have to map some data into those local registers. So again, not real difficult to do this, but I want to walk through it. Normally we just select the register mapping tab, and we might be mapping from the wireless network over. We might be mapping from Ethernet IP data over to a local register. In this case, we're using some Modbus TCP. So I'm going to enable the Modbus TCP, set its update rate, We're going to enable one device. We could do multiple. Call it the red line, and it is, we'll double check that setting. I believe it is 192.168. Yep, 8.39. And then I'm going to set a pretty fast poll rate for this one, but you wouldn't normally have to set it that fast, of course. So there's the actual device. And I'm going to head over to read rules within Modbus TCP, add a read rule, and I'm only going to need to do one. Red line coming from this red line device. I'm going to read, I'll say 15 registers. Now I'm going to start over here at local register 2, because remember that first local register was just a temporary register I created. When I expand this local registers in use, you can see all the registers I'm mapping, plus I have 4 spares because I mapped 15. So that is set, the mapping, and that now maps into the local registers. And we could even look at local registers in use, and it will show where those are mapped from. So you can see here, read rules. So I know that those are getting mapped from somewhere. So it's a nice check. So now I'll save that. I want to double check my cloud settings. That looks good. Okay. Okay, so now we're going to send this configuration. Make sure I saved it. I'm going to send this configuration to the device. I'll write something back in there again, so I'm sure that, oh, I got it while the device was rebooting. There we go. I'll do it again. Okay, let's just put something else in. Okay. I made changes to this file, so I now need to update that XML file. So I'm gonna, there's the new file. I'll go ahead and select my site, select Update XML. So every time I make an update, I'm going to have to go through this process. It's pretty fast, pretty painless. So now that has been updated. And you can see here, here's my data. My site ID did not change. Now when I go to registers, and I'm selected for the webinar registers, you can see I have all of this. Data. Now at the same time, I'm going to kick on my motor. And I should see this update once we get the first push through. Hopefully that's not too terribly noisy. I did reboot my DXM, so it may be another minute here. Yeah, I didn't get data. I was wondering what I had done. I didn't type in the correct address here for my demo site, so I'm going to fix that. So typos can get you. Let's come back here, and so this is not smoke and mirrors. We're doing this live. There we go. So I made an update. And I'm going to go back into that register and put something in there. Okay. And while we're waiting on that to update, I'm going to go look at some of the data that I've already recorded and explain how this works, the temp and vibe sensor. So this was the two vibration values. Here's the Z value and here's the X value. Additionally, you see this red line traveling through, that is the temperature. And you see as I mouse over it, it's telling me what the temperature was at any given point in time. I can take this data and actually download it here, and that creates a CSV, and I use that to create my actual baseline data on my motor. So I ran this for roughly 18 hours. It's recommended to run it for about 24 hours. And then what you need to alarm from when it comes to your motor data, your vibration data, is based upon your standard deviation. So a standard deviation is essentially what is the average variance of the reading from the arithmetic mean, or the average value. So if my average in this case was a 152 is the raw number, which is 0.015 inches per second on the z-axis, if that was my value, then I want to look at the standard deviation from that value, and then to set a warning level, it is 2 standard deviations away. So if I get specifically 5 consecutive readings, now normally we're not reading every 5 seconds like I am, we're going to read more like every 5-10 minutes or even longer, which is more than adequate when we're analyzing a motor over its life. So we're going to look at the baseline data. We say I've seen 5 consecutive readings that are at the warning level, then I'm going to enunciate a warning. If I see that's 2 standard deviations away. 3 standard deviations away is when I know the motor's actually getting close to its end of life, and it's close to a critical stage. So I'm going to set a warning threshold there. That's 3 standard deviations away. So to get standard deviation in Excel, it's very simple. Just do an equal standard dev.p or .s. P indicates it's the entire process size or data size, and the S is a sample size. There's really not going to be much difference there. And I did the standard deviation for both the Z and the X axis. Over here are the actual units in inches per second. And then I also, as you can see here, averaged or recorded the temperature data as well. So I use these numbers to integrate threshold values over in my charts and graphs. And you can see this is one of the beauties. I simply added I'll go ahead and clear the graph and go ahead and show how we did this. So here I've added from previous state this particular value. So there was the z-axis. Again, very simple to set this up. This is all on your site. The data is right here for you. I'm going to go ahead and say I also want to add maybe the temperature. In fact, I'm going to change that color because I don't want it to confuse with the actual alarm thresholds, and I'm going to add in the x-axis as well. So there are my values, but where do those rate relative to the thresholds? So my x-axis was actually crossing thresholds. So I went ahead and added an alarm and said, all right, I want to see the motor X data. When I add that to the graph, you can see now I have a yellow line and a red line. And then here's my motor X, and I'm going to change its color because that's a little hard to see. So I'm going to go to green. So now the motor X data, you can see where it crossed both the warning and the fatal threshold. Now I would not have normally alarmed on this because it wouldn't have been 5 consecutive readings. But for the purposes of this particular demonstration, I wanted to show the alarm. And then the alarm itself, if I select the Alarms tab, very simple to configure. Simply set that equal to my site and my specific tag, a greater than, set a warning value and a critical value. How do I set that up to send data to me? So I set it to my email address. But if I wanted to add another email address and say I wanted to get to my phone, there it's going to also show up in my phone. So pretty painless. Let's see if we can, there we go. So now on our webinar data, so we're getting real data again. Here you can see we have these values. If I go to, this is all from what we just set up. So if I go to my graph, let's clear this graph and let's go ahead and add, we're going to change the line or the site to the one we just set up, the webinar. Select the register. And we'll say I don't want to look at that test register. I don't really care about that. I'm going to add the motor axis, the z-axis. So here you can see, obviously I have a small sample size because we just started running this, but at least we can see that our data is populating. And we're going to change that to a green. So here's my x-axis. Let's go ahead and add the temperature. There's the temperature value running along. And you see that is currently at 81 degrees. Well, what is it actually? It's not at 81 degrees, it's at 70 degrees. So then if I want to see my alarm thresholds, well, I don't have one set up yet. So there's nothing set up. So let's go ahead and set the alarm from scratch. So here I have these alarms with the other site. I'm going to go ahead and set one with, I could specify, so here's my JW demo alarms, but I'm going to go to the webinars and you can see I have none set up. I'll select new alarm, register. We're going to call this motor 1 z-axis. We'll just call it motor 1 z-axis. We're going to pick the z-axis variable, a greater than, and I'm going to check those thresholds that I set. So it was 172 and 182 in the raw units. That's what I'm going to stick with. Now here I could set duration and set it so that this had to occur for, say, 5 full minutes, or 5 consecutive samples, whatever my time period was. And then I'll also add in my phone. And I'm going to save that alarm. I grabbed the wrong site. Here we go. I should have caught that. There we go. The motor 1 z-axis. That's good. So now that's in my That's in my new site with my new device, so I'm going to go ahead and create one for the x-axis, and this one is going to give me an alarm. I may have to start the motor again, but that one, my threshold levels were 106 and 117. And again, I'm going to email that to myself and to my phone. First time you set this to your phone, you're actually going to get a confirmation text from the Sensonic site to verify that you can receive these texts. So now that's set up. So the alarm is set, and the next time it logs it, well, let's see if it's actually at the threshold level, above that threshold level. So if I look at Z, it's a 111, and that should generate a warning. So I should get a warning email in a moment. So while we're waiting for the email, I'm going to go ahead and set up a dashboard. So we'll say, okay, it's webinar dash. We're going to select edit mode and set a new item. Do a simple graph from our webinar site, and we'll call this motor 1. And I want to see the z-axis, I want to see the temperature, and I want to see the x-axis vibration. And save. Now just like that, on my dashboard, I've got my my graph. I'm going to go ahead and add a gauge as well, and we'll make this my temperature. Give it a scale of 200 since we're in Fahrenheit. Say motor 1, and we'll say motor 1 temp. Again, we'll make that a little bigger as well. Then one other thing I'm going to do, this is very handy for looking at instantaneously, so to speak, the stack light or a machine status. I want to go ahead and set up a tower light here. We'll call this, now there's my warning I mentioned I was going to get. So here it is. I just got emailed the warning for my motor x-axis. I also got the same, at the same time, I just got a text on my phone telling me the same information. So here it sits at 116, which is above the warning threshold of 106. The way I'm set up, if this drops, I will get it to tell me when it drops out of that zone, or if it moves up into a critical zone, I'll get that alarm as well. And then in a second, we'll look at the actual alarms at the same time. So here I'm going to look at, this is module 1 through 4, bottom up on a stack light. So we'll say I'm going to go to running light. It's green, and we'll say running. We're going to pick up the maintenance status. We'll make that one yellow. Maint. Then I'm going to go to line down. We'll make that one red. And here you can see I got another email that I went into the critical stage here. So now I'm at 128. So now I've got a potential problem. Now, of course, this is happening way faster than it should. These are just spikes, but this is set those thresholds intentionally to try and pick some of that data up so you could see what would happen. You would set that normally for a longer duration so that it is a real value and a real concern, but that is going to predictively allow you to replace a motor in a time that will save you from obviously a downtime event. So now we're going to add also this status. Make that one blue. So module 4 is AB line status. We'll save that, and we'll go ahead and do that one, and then we'll add one more. And this one we'll call the S7 line. Here we're going to say S7 is running. Just pick the correct tags, the maintenance, down, and I don't have a status tag configured for that one. A little bit of play here. All right, now I will save this dashboard. And then I'll exit the edit mode. You see here my alarm is cleared. I'm all the way back down to 102. So if I went and looked at my graph now and then hit the refresh button, you can see it's already dropped. This is where I can now add an alarm value, and since I've now configured alarm values, and there's my x-axis alarm, and you can see I'll add the z-axis alarm also. You can see the z has really stayed free and clear other than the initial spike, which we would never enunciate off of. But now you can see this is clearly we've dropped below the 2 thresholds on the x-axis. So that's running smoothly, and then of course since the motor is running, we're slowly climbing in temperature. So now I go back to my dashboard, and here I have configured these 2 devices, and they're both in a running state. So I'm going to change the state. I'm going to give the Rockwell machine a status, and I'm also going to go ahead and put it in a maintenance condition. And then over on the S7 side, I'll just do something simple and make it a fault condition. Now you can set these to auto refresh at 5 minutes. That's really more commonly what you're probably going to do, but I'll go ahead and keep refreshing until we see the data. Now I didn't set any alarms off of those values, changing states like that. So we're on that minute cycle, so we're just waiting on that to appear. If I go back to the alarm history, you'll see that this is clear at this point, this particular alarm. If I go to the site, let's go over here to the register actually. So here's my current status again. Let's see if I've got on my dashboard any good data now. There we go. So now I have a flashing blue. I have a main light on my AB line, and now my S7 line is down. And we'll change that. So just go ahead and put some different values in here so we can see. And it'll take up to a minute. But one of the things that's really handy when we set these values, you can see my motor temperature is continuing to climb. My vibration data is starting to stabilize, which is what I would expect after the motor starts running. And then I go over here to my dashboard. Should be seeing it shortly. There we go. So I changed status. Now if I were to click on, say, the AB line, the tower light, and select item view, I'm actually going to get some statistics that tell me, okay, this is how long it's been running. This is where my status indication was a solid blue, for instance, or 82.8% of the time. And then I actually have how many minutes I was running and how many minutes I was in main mode or fault, just based upon me entering those values and giving them a proper description. So if I go to the S7 line, I'll have something similar. So again, this statistical piece of information has been taken care of for me. So I'll go ahead and there you can see I hit warning level again on my motor, my Z-axis. And each time I've had that, I've also had it show up on my phone, same way. To access this data on your phone, you would simply log into the site. Now I'm using the demo site. It would be the banner CDS. Then your login, and you have access to this data. Some of these graphs, this is very handy for, like, for instance, when I did the baselining, you can actually download the graph, and then when you download the graph, you can get all this CSV data. That's where I generated all of this data. It was just simply pulling straight off of the graph into a CSV, which I then turned into an XLSX so that I could do some manipulation of it. So that was the whole demonstration. And we can do, again, these pre-configured kits. We can do far more, and you can certainly add far more to this site. I hit the critical level. So with that, I'll check and see if there are any questions. And if you have any questions, now would be a good time to ask. So just as a review, this is what we hooked up. So the heart and soul was the DXM100, and then connected directly to the Banner CDS. So are there any questions at all? And this will be made available on our YouTube page. As well, so this is one that you could walk through again. If you do have an application, let us know, and we'll come out and analyze the application with you and make sure you have the right hardware and help you set it up. Some of this is just going to be all based entirely on wireless, but in other cases you may be interfacing with other PLCs or other devices.